Hello everyone, welcome to the stream where we do some FPV electronics repairs and we pretend we know what we are doing. How are you all for this English stream? I see we have a few people in the chat already. Spawny as quickly becoming a regular. Big Mama, Mika, Feet as always. Oh, Aromiel, I don't think I've seen you before, or maybe I'm bad at memory. That's very possible, but welcome to the stream. Today I have something special that I've been wanting to address, to kind of investigate for a while. And let me jump straight into it, and I can show you what we're going to be doing today. So I have this, my test quad, and has an ESC that come from a friend, and that seemed to work. However, if I plug it in and give it some juice, I'm going to give it 4S, and I'm going to show you. And if you look here, when I'm going to turn it on, and I'm going to spin the motors, and I want you to have a look at the RPM value. And if you can see here, a bunch of motors are spinning at like almost 12, 1130. I think it's more noticeable here. So 7600, 7600, 76 or 7700 here, and 63, 62 here. Motor 1 is consistently spinning slower. And that's an issue that's reported quite often, and I never had an ESC that had this problem before, and I want to understand what's happening, because the issue when you have an ESC like that has a motor that's been slower is, first of all, that motor is often more prone to desyncs, but also it means the power of the quad is reduced to the slower motor, so you get like you're feeling like you have like 25 less power, and that's absolutely awful to fly with. So that's something we want to have a look at today. And I have had a quick chat with Liviu, who's the Voltara ESC creator that I repaired on stream the other day, and he suggests that the most likely thing is the MCU on the ESC. So we're probably gonna start by swapping two MCUs and seeing whether the issue follows the MCU that we moved, or whether it's still on motor 1, and that will give us information on how to proceed next. So yeah, we have a few other people streaming in, sliding in the chat. Alexis, hello. We have Fable, hello. Welcome to the stream, and Clem as well, welcome to the stream. So yeah, jumping straight into it today, I'm gonna take this apart quickly. I can give you an overhead view, and I'll take that ESC and start swapping parts until this motor, which is pretty sure it's motor 1, yeah, motor 1, so we'll remember motor 1, until this runs as smoothly as the others. I have here stashed a donor, that's one of my donors, and it has the right MCU, it has the right FETs, so we'll be all good. If we need parts, we can get it from there. Sporny suggests to use a higher kV motor on that channel. Yes, but then desyncs, and probably not good things. I expect stacking a more demanding motor on a very tired channel is probably not what you want to do. But, I mean, in principle, that's a somewhat logical idea. But yeah, probably not the right one.
Well, I think I said the driver or the MCU, and the MCU was the prime suspect.
Yeah, so I'll start with the MCU, and if it doesn't work, I'll swap the driver. That sounds like the most logical. As always, if you guys want to jump in on chat and ask questions, or just chat about repairs, as long as you're not basically holding the chat forever, you're absolutely welcome to join me on chat. The link to the Discord is in the description of this video, and you can just hop in chat. You are very welcome to also stay at home, chill, put this on your second monitor, take a nap, listen to the story of electronics being repaired. That's really up to you. I appreciate any and each of you, regardless of how involved you are in the stream. It's really good to know that there are a bunch of people watching the streams on demand afterwards as well. It's really nice. I've got some good messages from people who said they learned a bunch of things. So, I mean, that's what I try to do. Try to communicate my knowledge as much as I can so that more people will want to repair stuff and we can keep our electronics out of the bin. Because, I mean, it's not the most expensive electronics in the grand scheme of things. It's not an iPhone. But saving 40 bucks every time? Yeah, I'm all for it. Would you have a few messages? Yeah, Mika is mentioning the classic RPM issue, and I know he has a bunch of ESCs that do this, so he probably wants to know the answer as much as I want. And yes, having an he points out that having an oscilloscope could help me track down the issue, but I currently do not have an oscilloscope. If you know people in the oscilloscope industry, tell them that I want one. They should send me one for free. That's what I need. A free oscilloscope that work better when they're free.
What firmware does it run?
That's a BLS, so Blue Jay. This one. Yep. No, I'm not gonna spend hours trying to climb this. So yeah, that's a Blue Jay ESC. So the MCUs are actually tiny. They're 5 millimeters by 5 millimeters. So that's going to be a BB21. Yeah, those are indeed. And I think the drivers are 4-char. I can't remember if they are or not.
Yeah, it's the Chinese driver.
Yep. The one that you can, when you search for the data sheet, you only find the Chinese data sheet. Let's remove the gummies as well so they don't annoy me during the heat process. Hey Romain, you're here to improve your English, yeah? Well, feel free to do that. It's always a good thing to practice. And if you want to jump in on stream to practice your oral skills, that's even more. That's very doable, but you would be quite courageous to do so because you'd be speaking in front of many people, the thousands and thousands of people who watch this stream. Okay, Armin, you've been only in the comments, so yeah, welcome to the live stream this time. Spawny is noticing my new camera setup. I've done the overlay and everything because I'm a professional now. I'm not a professional, but I pretend. But yeah, hi Mike, and you're very welcome. I try to teach everything that I know as much as I can. And if you guys have any question, whether it's related to repairs, FPV electronics in general, if you want to know how some of those parts work, I can give you an overview, I can give you details. Feel free to ask any question you want. If you want to make sure I see it, I do come back to the chat every once in a while, but when I have my head in the microscope, I might miss a few things. So you can always tag me in the chat. You just write my name, Krhom, Krhom, and I will see it on orange, so I can make sure I answer the question. But yeah, absolutely feel free to ask any question you want. Right, let's go to the microscope and have a look at what we're going to be doing. So here we have those parts. Let me grab tweezers. So yeah, we have 4 times, it's a 4-in-1 ESC, so we have four times the same thing. So here we have some power conversion at the top. something that brings the voltages in the range that the other components need. And then for each channel, we have an MCU, which is the thing that we want to swap first, a motor driver, which is the thing that turns the FETs, the big components on the other side, those ones, same as those ones. They turn them on and off very fast and very cleanly. And then we have a bunch of passive components that might also be sources of like issues. But what we're going to start with is find out the right motor first and remove the MCU from this one and swap it with another channel. So we want motor 1. Where is the... There we go. So that's motor 1. So that becomes here on the right. So what I'm going to do is remove this component, put this one here, and see if that gives us full power on motor 1. And I might not solder the other one back until I know for sure. And we can always run with only one MCU anyway, or with one missing MCU. We have a question. Sporny asks, I have a basically new 2S AIO where the FL411 needs to be swapped. Could I help with that? I can't help you. I can't do it for you. I don't do repairs on demand. That's something I just don't have time for, and I don't think I have the confidence to offer it as a service. However, I've shown how to swap the MCU a bunch of times, and if you have the equipment or someone who has access to the equipment, it's a fairly easy thing to swap. Unless it's a super well-integrated AIO with some with a chip that's a bit smaller, has balls on the bottom, which is called a BGA chip. That's harder to do. But yeah, I can't really do it for you, unfortunately. I just don't have time between everything else I do and work and everything to offer it as a service. But I'm happy to help guide you, absolutely. Frederick Michael asked, how often do I break a 04 on the KU Mini? I've broken 6, not all of the KU Mini. I probably broke 2 on the KU Mini. I would say every 3 or 4 sessions. But DJI has not made me pay anything yet for them, so that's quite nice. Let's get some tweezers and let's start heating things up. So I'm gonna start on 400 and probably push the airflow to fairly high, 80%. And I'll try to warm up the board first. It's not the most expensive board. It doesn't have a ton of thermal mass, so I shouldn't have too many problems pulling the components. So I'll still heat up the board a bit. And then I'll come in and heat up that specific chip and pull it out. It's nice because there's not too many components around it that I can accidentally push. There we go. That's coming right off. I'll put it aside. Then I'll pull the one just below it. Give you some eyes on it. So that's a known working one. So I'm going to pull this one and put it to the side. Yep. Did I notice the direction of the thing? I probably should have noticed the direction of the thing, but given, yeah, it's probably in exactly the same orientation because it has the circuitry, so I can see the test pad above and going to that. And it's the same kind of shape here. Can I get confirmation? And if you look at the other side, they're oriented the same direction both, so it's probably the same direction. Can I get a clear confirmation? There's no indicator for pad 1 in this, but I'm going to risk it and put it back. I'm pretty sure it's the same direction. I could go back on the stream and double check, but writing is very hard to read on it. So Sporny has, you broke the plug on your O4 and you had to resolder it. That's a very common issue. I've had it twice. And that's because I put the O4 plug next to the front standoff. It happened twice. One on my machine, I broke a friend's machine that way, and he broke mine the same way, and I repaired them both. But now I've rotated the O4 180 degrees. It shouldn't happen anymore. But yeah, the plug kind of rips out. Thankfully, it doesn't bring the pads with it, so it's easy to resolder. Clyde is breaking his Kayu Mini every 5 to 10 lipos. I can attest to that. That is a real thing that happens. But yeah, it's definitely an argument for analog. I agree with you that it's something that's you do break them less on analog. Though I'm happy to do the repairs to get to fly it digital because I enjoy it more. It's not the case for everyone though, so that's absolutely fine if you don't. I'm gonna put some flux and try to just solder it back on without any kind of extra leaded solder or anything. It seems to come in fairly easy, so I'm gonna risk it that way. And if I fail, I'll just do it again with some more. So I feel it being tacked in place. Yeah, it's tacked in place, so I'm going to put some more flux and reflow it. But that went quite quick to tack it, so the board is still hot. I probably should have done it before going to chat to you all to ensure the board was still hot, but I can do it now. I'll lower the airflow a tiny bit as to not chase the flux so much. Well, let's do it. And now we're waiting for the solder to melt and the chip to kind of shim in place, possibly, if it's not exactly in place already. You can see I can see it all melting. I try tapping it. Yeah, I think we're nicely in place. We'll give it a go, see if it communicates with the flight controller. So now we are expecting to see 3 ESCs because I didn't put back the other one, and we'll see what happens. Frederick asked if it's usually fixable instead of buy a new broken. If you're talking about O4, you can just send it back to DJI. And most of the times you don't tell them anything about how you broke it. You just tell them, it no working. They will send you back a free one. That's what's happened for me all 6 times, and I've sent them pretty damaged ones. If you're talking about FPV electronics in general, I would say as long as it's not completely burnt away, like there's no burn stuff, then it's probably repairable, possibly. It's hard to say. But I've had a good success repairing stuff. I'm going to try to, I'm blowing on the board to cool it down because I don't want to burn my fingers. I also don't have a ton of confidence on running a hot board. I know resistor values go down when you heat them up and a bunch of things like that. So pretty much want to run it at a decent temperature. Let's see. Okay, it's warm, still hot. Let's see if I put back this thing correctly. Let's see if it communicates at all. put the donor somewhere else. Put this right here. We'll want some alligator clips. Plus is here. Minus is here. Plug it in and see how many ESCs we breed. There we go. Let's go to screen share. So we see all 4 ESCs because there's not been any communications. I'm going to turn it on now. I'm going to put over current protection just in case I mess something up. And we should see a certain number. There we go. 3 of them. One is still disordered, so it's not communicating, but the other ones seem fine. So now we want to check if motor 1 is still differing to the other ones. So I'm gonna need to solder it back on and put some, I think we're gonna be soldering and desoldering motors a lot today. But then we want to know, we want to understand. So for science, I'm gonna do the motors 20 more times if need be. Salut Xander. Welcome to the stream. Tonight's in English. French is on Thursdays. So you're welcome to practice your English. Can I do yeah, I should be able to do the alligator clips. So I just need to solder a few motors. Let's do that quick. Is the Caillou Mini a good quad for somewhat beginner pilots? So it's not an easy build for a beginner. It's a fairly technical build. It's very small. So that's one thing. In terms of how it flies, it is, I would say if you're building it analog, it's probably a very good quad because it's light, doesn't break much. It's fairly cheap. The batteries are cheap. The charger is cheap. The spares are fairly cheap. So it's really a nice way to start. Because of how fragile 04 is, building it at as your first quad on 04 is kind of asking, I mean, you're going to lose time. You're not going to lose money because of the repair service, but you're going to lose a lot of time building it back up and again over and over. So there is no real way to kind of make it indestructible with 04. Though if you're flying in fields, if you're flying in like nature, it's probably fine actually. We keep breaking it because we fly bandos, we fly in concrete, we smash into walls. So yeah, that's gonna lower its life expectancy quite significantly. But if you're just flying in nature, parks, stuff like that, maybe you'll be fine as a first one as well. It's a good format to start on. I think it's one of the right formats to start on. The other two would be tiny whoops because they are pretty much unbreakable, and a 5-inch because it's the easiest to fly. You fly it very wide in a big field and you don't really take many risks. So yeah, that's a good way to do it. Let's plug this. I don't want to have to solder a pigtail every time, so I'm going to try running the alligator clips in the frame. Should be okay as long as they don't touch carbon too much. So what we're going to be looking at is whether the motor 1 spins at the same speed as the other two this time, whether it spins at all to start with, because we did swap an MCU. And I might not have soldered it correctly. That's very, very possible. And if it does spin, whether it spins at the same RPM. Yep. Let's put those motors wires somewhere. Okay. That's well connected. Let's go back to screen share. And let's see. Turn it on. And what are we expecting to get? So 600 and, oh, okay, so it's not it. It's still running slow. So it's probably not the, well, it spins, that's good. But it means it's probably not the MCU then. So I'm gonna put the other one back. And we're gonna try swapping something else. We're gonna try swapping the driver. And see if that does anything. Do we have... I have a few questions. What's the main selling point besides that you can fly it everywhere? A good selling point of the Caillou Mini versus a bunch of different other formats at this size is that it feels like a heavier quad. It flies like it's heavier. It's very similar in terms of feel to a 5-inch in some respects. Obviously, it doesn't have the same power. You can't go at Mach 10 speeds, but it's very impressive how good it feels in terms of feeling like it has weight. So and you can indeed fly it in many places because it's nearly silent, and the price is definitely lower than a 5-inch. So that's a bunch of arguments for it. But if you have the room to fly a 5-inch and the locations to fly a 5-inch, I probably would recommend that first because it's one of the most durable formats. It's one of the most well-polished formats. It flies well straight up out of the box or out of the build. And it's a well-understood format. There's plenty of spares. Yeah, so it's also easier because you have more mass in the quad, so it's easier to fly. You have more time to react. You fly bigger spaces. So yeah, there's the arguments. Frederick says, "Sadly, we don't have bandos in Munich. You have a bunch of bandos in Germany. You might have to go to the roads and try to reach the lovely German bandos." If it's not the driver, says Liviu, it's the passives around the driver. So it might be worth me trying to measure the passives after I remove the driver before I put it back on. But I'll see first. I'll put the other one MCU back on, so before I lose it. And so I'll try to, yeah, so it's going to be upside down, no, right side up. Let's go back to microscope view. My tweezers. So we're going to want to put it back the way, it's really hard to read. Yeah, I have a view that's easier to read. It's very dark, but at least I can read. Can I increase brightness? Yes. There we go. Thanks to polarized light, we can see stuff. It's all very dirty. You can see how dirty it is, which is funny, but you can see the text way better. So yeah, that's nice. I guess it was the right way around. It's just interesting because those three are the right way around and this one is the other way around. That's very interesting if that's the case, but no, it's not. It must be the same as this. Oh yeah, it's the same as this one. I'm very confused. It needs to be the other way around. There we go. It needs to match this one. That's the one I replaced. It's just I had the whole board rotated before. So let's do the same thing. I'm going to put some flux on. I'm going to heat it up till it's stacked, put some more flux and reflow it. Seems like it worked before, so I'm going to do it that way. So the board is colder now, so it's going to take a bit more time to heat up. And try to not ping off the thing to the other side of the world. I can see the solder is already melting to some extent. Is it? Not sure actually. No, it's not. It is not. Oh, there we go. Now it's melting a bit. Trying to do, oh, I'm touching a passive on the side. I managed to. Okay. I'm not even remotely melted. I'm going to try to not hit the passive on the left, which is a resistor. Probably should have heated the board beforehand. Would have had a better time. Am I? Yeah, so I see it kind of melted to some extent, but I'm gonna put some flux and reflow it. Lots of flux. And yeah, that's not as clean an installation as the first one because the board wasn't hot, so had more difficulty. There we go, now it started snapping into place. You saw that, right? It jumped into place. So now I'm gonna remove the driver. So that may be our bad driver. That is possibly our good. That is our good driver. No, that's not the case. That's our good driver over there. This is our bad driver. There you go. Put the bad driver here. Put the good driver back on the board. But we're going to measure some passives around. So this is our good driver. And I did move this passive here, but that's okay. It stayed in place. So there's a bunch of things that go. So those resistors are mirrored here. We'll see if we can find. So this is our bad channel. So I'll measure all of this and see if I can see discrepancies. And I'm pretty sure this is the pull. What's it called? The pull-up capacitor or something like that. I learned the name earlier today, so I can't remember. But it's an important cap that's used to pump up voltage to be able to open the high side MOSFET, I think. Tell me if I'm saying bollocks, but I think that's the case. Hey, CMYK. Wouldn't it be better? Romel asks, wouldn't it be better to tidy up, to clean up the board with some alcohol and toothbrush before soldering? It would be. It would be even better to wick up the solder and then put some leaded solder. It would make it easier. But that was the lazy approach I took, basically. So I think I soldered it back on well. So yeah, I guess it kind of works. But it's definitely, if you want to do it, put all the chances on your side. You would want to clean it up, add some leaded, wick everything, and then put some leaded back on and solder it back up. That's the best way. I do that for MCUs. I have a better success rate when doing it with MCUs. So which testing resistance. So as you can see, I now finally managed to install the multimeter display, and you should be able to see the multimeter activate and start displaying stuff on the top of the screen. That's pretty cool. Let me kind of, I'm gonna blow on the board a bit just so I can get the resistors to a normal temp so they don't read weird values. LiveU is recommending to swap the driver first. I'm going to do a quick check on the resistors just in case. It doesn't take very long. But yeah, it's probably worth doing the swap. Oh, yeah, well, I just forgot I had a driver on that board when I blew on it. So the good driver's gone. I'm going to have to take one from the donor. That's fine. I have the donor. Yeah, I had a chip on this. Why is it? Where's my good driver? Yep, I think it's gone forever. I'll take a donor. That's fine. Let's do this while the board cools. So this one's the bad one. I'll put it in a small box. And I'll take my donor, which is over here. I'll steal all its drivers. It's the same, right? Oh, it's not the same driver. I need to find the same driver on another donor. That was not very clever putting the chip on the board, was it? Yeah, there's absolutely no chance I'm going to find this anywhere. So I'll see. I know I have a bunch of donors that have that 40R chip. Let's make sure we know the name. It's 40R FD62288Q. We'll see if we find something that's similar. The numbers on it are not necessarily everything. That seems like it's a 40R chip. That's conformal coating, but it is the 40R chip. Let's hope there's only one. Let's see if I can get the text readable by trying to remove the conformal coating on top. There we go. Can we read it with the polarization? A bit of cleaning after that. I think it's probably the same one. LiveU says all of them use the same one, even if they are different, meaning the text probably doesn't matter. I'm guessing if the number is different, it's the same roll. I'm hoping. Let's see if that. And I guess we'll quickly see if it spins at all. It's going to be an easy way to know. Yeah, that's what happens when you don't really know what you're doing and you're learning on the job. You don't really, you tend to make mistakes. I'll quickly extract this one. I'll ramp up the airflow to maximum. Come in, try to do it quick. You don't have the smell, but I don't know what happened to this ESC, but it smells very bad. All right, so I'll put it here and try to not lose it this time. All right, so back to testing some passives with my new multimeter display. Now the board has had time to cool, that's good. We'll put it back here. And we're trying to compare the two here. So I'm in resistance mode. Hopefully now that we remove the driver, the resistance shouldn't be affected too much by anything. But what do we have here? 2.7, about 10 ohms. And this about 10 ohms. Takes a while to stabilize. Right, about, let's let 10 ohms. Oh, they might all be 10 ohms. Let me check if they're all 10 ohms. Oh, that's 10 kilo ohms. Were they 10 kilo ohms before? I thought they were 10 ohms. Oh, that's, okay. So that's 10 ohms. So first two are 10 ohms. The next one is 10K. Right on the dot slow. Let's try the second one on the right. Oops, I slipped. Those are tiny components. So that's 10 ohms. Next one should be 10K. Yeah. Then we have 10 ohms again. 10 ohms again. Oh, 10, was it 10 kilo? 10 ohms. Was this one 10K or 10 ohms? I need to make sure. Oh, 10K. Okay. So we have 10 ohms, 10K, 10 ohms. And let's try on the bad thing. 10 ohms. 10K. 10 ohms. Okay. So those resistors seem to be fine. Let's try this. 10 ohms. 10K. And 10 ohms. Okay. Well, I guess they really want to reuse the same values as much as I can. That makes sense. It's called bomb consolidation, where you try to only use certain values. And 10 ohms. Okay, so we are good on the... Oh, what do I see here? What do I see here? Now, let me try to focus. It might not be completely focused for you guys. I can see something, though. That's a diode. What's a diode doing here? Let me see if, yeah, you have, so I just noticed this, but this is damaged. And those are diodes. What are they used for? I'm guessing it's part of the design of this, but I'm gonna swap that, see if I can find a donor on another board. Yeah, Liviu says you should have 6 10 ohms per driver. I think those are the gate drivers, if I believe, the gate driver resistors. Spawny asks, what kind of magic enables me to have a multimeter on stream? Well, thank you very much for noticing. I bought this. Can I show you? This thing is it's not even a great multimeter, but it's a O1 XDM 1041, and it feels like it's worse than the multimeter I had before, I was using before, which is the not very expensive Unity portable one, but it has a USB connection, and there's an app called Rustimeter. It's written in Rust, and that lets me have a display and it communicates through USB, and I can have the data display on stream. And that felt very important to me because a multimeter is the main tool we use to diagnose stuff. So, all right, let me see if my donor has the diodes. Looks like diodes. Let me, I guess I'll do the removal replacement and putting back the drivers. I'll grab another driver. I'll put 2 known good drivers on this. So I'll grab one of those diodes and a driver here from here. Those diodes are absolutely small. They're very small. So it's going to be fun. Can you see? No, you can't. Now you can. So yeah, those are the diodes I want. I'm going to grab those. Oh, Liviu is explaining that it's called the bootstrap diode plus cap because the driver doesn't have them inside. They are Schottky diode. Thank you very much. I did not know that. I don't know much about. I'm starting to learn more and more about how all those boards work. And it's very useful to understand how they work to fix them. But I still have gaps, especially around driving FETs, FET drivers, and all of that. This time I'm not gonna be. I'm gonna be clever and heat up the board. But first, I'm gonna grab a small box that I can use to put the small diodes in, so I don't lose them because they are very, very small. I think I have a bunch of motor boxes here. There you go, those small boxes that you get when you buy tiny motors. And this one has glue in it. That's fine. Glue is fine. Let me remove those components. I'm gonna grab a bunch of diodes just in case I mess it up. But first, I'll heat up the board, and then I'll get a driver as well. So hopefully that sorts it. I mean, the fact that the diode is broken is probably very relevant to our issue. I mean, I don't know if it is, but it's a broken component on the part of the thing that doesn't work, so sounds like a smoking gun to me. Oh, that's one gone. That one's not gone. That's why I want to grab a few. I'll grab another one. That looks good. Here, there's a bunch here. Let's grab them. Let's grab this guy. There you go. Managing to read their orientation is going to be a fun task, I guess, because they are conformal coated, so it's hard to see what's in there. There we go. Heating up the board really helps. Let me grab another driver just in case. You know, I don't lack for donor boards, so might as well. I have no reason to think those would be damaged. This board was clearly dead by fire. So yeah, no reason to think the drivers themselves don't work. So yeah, that's one's going away. Nice and hot. Now, my board. Let's put it back. Technically, so let me remove the bad diode first. Heat up the board, remove the bad diode, and then we'll put some flux, try to put the diode back. Let me heat up the board first. Let's do it nice. Try to reduce my chances of failure. The chances I'm gonna move the cap next to it are very high because it seems to be getting close to it. Kind of has leaned over. Okay. Oh, there's one other good thing. I took a few of them. I grabbed a few of them because I managed to move another one. Let's put some flux and see if we can reflow that cap correctly. Yeah, I probably have too much airflow. That's a sign of too much airflow. And because I move stuff around. So I'm gonna put some flux here, lower my airflow. I was max airflow, so I'm gonna move to 50%. And try to put that cap back. It might just pop back. And if it does, I'm going to try to come up from above as well. There we go, that's melted. There we go. Okay, so now I'm going to put some more flux. And, oh, I managed to put some flux everywhere. That's awesome. I'm going to try to grab my donor. So can we see the mark on them? That's the question. Ah, that sucks. We can't see the mark. The mark will tell us what direction it's supposed to go. And because of the, let's see if the polarization can save us. You can see here the line here on the one on the board. And on the one I have, I can't see the line. So I'm going to put it down and see if I can scrub the top of it to reveal the markings. Or I can see if my other donor has more legible ones. That would be easier. And that's hard to
just
read.
measure it, but you will
Oh, yeah.
be at risk to have it jump around when you try to
Yeah,
measure it.
I can try to measure it. I'll try to measure it. That's a good point. It needs to pass with my red probe on the right, because the symbol here is saying the diode is supposed to go that way. So let me put it down here. And then I need to not... I'll see if I can scrub it first, just because I might lose the plot halfway through. And yeah, this is absolutely tiny, by the way. I think that's 0402 size, I think. Ah, there we go. Pinged. And it's lost. Okay, what I'm going to do is look through my donors to find a board that has a diode that is readable. Let's see, I'm bound to be one somewhere. This guy? Nope, that's built. Oh, there's a bunch of diodes here. Do you know if they would do those diodes in the middle? Because they do have the mark. T4. I'm guessing they would probably do. There's no other reason there would be a diode here, right? Otherwise, do we have one with the diodes on the edge, the same as we... What I can do is remove it from a donor and keep it in the same orientation as I move it as well. But this looks like they would do the trick. It's just not the same driver, so I'd rather have a board with the same driver. Let's see if I go to this donor and... Oh, I can see the text on these, so I know T4 is facing up. So that's probably good enough. T4, T4. All right, let's try this. Let's try. Do we see on my operation board, the one I want to operate on, do we see T4? Yeah, so I just need to match the text on it, so that's fine. I can do that. Let's go back to the donor and grab a bunch of diodes again. I'm cleaning up my small box. And do you guys see correctly? Guess we can do that. There we go. It's probably not as good looking as this, though. Yep, let's go for some diode surgery again. Thankfully, I have a bunch of donors because, yeah. Oh, the one that with the visible text were these ones. There we go. Let's grab those. I'm just trying to they keep sticking to my tweezers, of course. There we go. 2 of them. Let's grab a third one. Because why not? While we're here. Ah, it's stuck to my tweezers. Go away. Go away. There we go. And third one above. Let's rotate. Rotate. Up. There we go. and still stuck to my tweezers. That's fine. I can use my other finger. There we go. Okay, hopefully with 3 we managed to put back 2. What are the chances? Did I tell you guys I don't know what I'm doing? I don't really know what I'm doing. Let me do a quick catch up on chat. Yeah, that was too much airflow. You are right. So LiveU is certain that it's the diode is the problem. That wouldn't surprise me. Let's first try to fix the diodes, to put the diodes back. It's good training for me as well, putting the small components like that back. Let me also try to clean up my tweezers that I managed to put a bunch of flux on. All right, let's see if I can. So yeah, for those who, I like giving a quick size check, but those are the small dots here. That's the diodes. So yeah, small stuff, fun stuff. All right, let's me try to grab one in the right orientation. So we want the text, which should be readable to some extent, maybe with polarization. And so that's upside down. So I need to rotate it, try to not ping it to the end of the world. If I need, I can always extract some more. Okay, now I'm gonna try to get a good grip on my tweezers, because if I hold them too tight or something, it's gonna ping to forever land. I'm gonna come, try to tack it. Oh, try to tack it in place. There we go. And then I might just come with low airflow and reflow them afterwards. Let me grab another one. Let's see if it's the right way around. Can't see. Oh, that turn off my heat. Take my time. Can we see T4?
You can reflow them when you place the driver.
Yep. Good point. That's the right orientation. So there we go. I know that's now tacked. The drivers. So thankfully those have a marking, so I know the orientation. If you don't know, most of the time people who design circuit boards, they do it the right way, and they put a mark here on those chips to tell you where pin 1 is. So I think pin 1 is under. I think that's going counterclockwise, but there's going to be a mark on the chip as well. I will show you. It's this mark here, dots, so I need to align those dots together. But I first need to put a bunch of flux here, so I can reflow this chip. Let's keep putting some flux everywhere. I need a better location to put my flux all the time, but let's try to use those tweezers actually. Here they're better. Put some flux. I'll put some flux over there. Those I need reflowing as well. And I'll keep at 50% heat, so I don't, at 50% airflow, so I don't start chasing components away. And I'll heat up the board a bit more than I did before. And then I'll come drop it as before. I'm gonna tack it. So basically heat up and try to put it on in a way that it just gets attached. Oh, you can see the diodes are being reflowed. So yeah, here, I know, I saw the solder move here, so I know it's melted. So now it's attached, but those pins at the top are not even remotely flat and touching. So I'm gonna come with some flux. and I'm going to reflow the chip, and I think the diodes have reflowed themselves already, but I might come and try to lay them flatter. So here we're waiting for the chip to pull itself together, kind of jump into place like we'd had before. It's starting to melt, so it should happen fairly soon. There we go. They jump into place, and it's nice. And let's try to kind of flatten those. There we go. That's one down, one to go. And we'll do exactly the same here. Put down some flux. That is going way too smooth for my liking. I don't. Yeah, there's something that's gonna go wrong somewhere. It's happening way too well, but we'll see. So here, pin 1 once again goes to pin 1, so we need a rotation. All right. Let me heat up. The board being hot shouldn't take too long. I can feel it already being tacky, but it's not in place at all. I want to move it closer to its final resting place. There we go. So it's tacked. It's going to be tacked. It's tacked. Come back with some flux. And wait for it to lock itself in place. So I'm trying to go from the top as much as I can so the chip doesn't want to move and any other chip around it doesn't want to move. And now we're just waiting for it to go down. It's melting, should happen soon. So it moved a bit. I think it has moved enough, but I'm not sure it's high enough. There we go. There we go. Oh shit, I moved it too much. I'm shitting myself here. I think we're good here. I think we're good here. Phew. Yeah. It's funny to see all the solder solidify and become dull because it's unleaded solder, so it doesn't stay shiny. All right, I think we should be good to test. I still have all the diodes, new drivers. Okay, we're hoping for success here. Only took me about 20 diodes who have died for this cause. I'll find diodes on my mat for weeks to come. Oh well. Hopefully, so I managed to put back 2 drivers and 1 MCU and 2 diodes. If nothing is broken and it works, I'm going to be very, very happy because that's not stuff I'm used to doing. So yeah, that's going to be fun to see. Let's go to the other head, install it. You're going to see me solder some motor wires for the 20 millionth time. Let's kind of blow on it as well. Also, this is a no-name ESC. It's probably like 30 euros tops ESC, so we're saving very valuable parts here. But as I said, the most important to me is to figure out why it's spinning slower. So I'll spend a few seconds cleaning it, actually. For those who haven't seen the cleaning process, now my preferred way at the moment is to use those nano cleaning sponges, and they're already half full. They're really nice. You just take them, use them with my self-closing tweezers. I have one of those IPA dispensers. You just have to squeeze the top, and it's gonna dispense some IPA, and you can kind of soak the sponge, and then on the microscope you'll see it just grabs all the flux It keeps dispensing alcohol, and it grabs all the flux inside the sponge. It's really nice. And you can see the sponge is dirty, which means it's done its job. Here the board is very, very hot, so it's the alcohol is evaporating immediately. It's not doing as good a job, but it's still much better, and the sponge is dirty as it should. And that's also going to cool it down because of evaporative cooling of the alcohol. But yeah, it's still hot, so I'm going to blow on it a bit. Feel free to take your bets on how likely it is that I either didn't resolder something correctly or wasn't the issue. Yeah, let's put this back on. The solder on the back is doing weird things because it's being heated and cooled many times by the hot air. Let's go. I'm going to solder all 4 motors this time because I need to test that the one I put back is still good. Motor 2 that was. I'm curious to understand what the diode does, but I'm guessing it's part of the, you said flyback diode. That makes me think it's part of the circuitry that opens the gate for the high side MOSFET. If that's the case, I could imagine that it not working well would make the high side MOSFET not open as fast or something like that. That's very much reaching to the end of my understanding of how FETs work. If only I knew someone who could teach me all of this. I'm saying that because I know someone. And I will need to learn all of that at some point. So I can tell you guys. That will be helpful for everyone. But yeah, now I have keywords I can search as well. It's quite nice. So I noticed when I was looking through my donors for diodes, so that indeed some boards don't seem to have them, meaning they're probably integrated to the driver circuitry, which is nice because it means fewer components to go bad on the board and to generally have in your bill of materials, so you don't have to. It might be cheaper to produce or something. I'm guessing the driver is going to be more expensive in that case, but I don't know. I haven't produced any, and I haven't yet designed any electronics, though I do have plans to try my hand at them. So Liv is saying you have high side FETs and low side FETs. That's something I've explained on the stream a few times, but if you guys want to know more, I can always tell you again. And yeah, so that's what I was thinking. So basically, because they're all of them are N-channel MOSFET, which is a type of MOSFET where you need to give them more voltage than the source being one of the 2 outputs. Like, let's go to the beginning. A MOSFET is a switch that can be toggled through voltage. The switch has kind of a line of current that can go from drain to source, or yeah, I think that's from drain to source, and the gate is the thing that opens it up. And for to open an N-channel MOSFET, you need a voltage that's higher than the source. But when your high side MOSFET, which is in between VBAT and the motor pad, it's possible that the source, which is the motor pad, could be as high as VBAT, depending on what's happening with the motor. So to open the FET, you need to put some voltage that's higher than VBAT. And apparently, with the magic of diodes and capacitors, you can do that. And the driver, obviously, the driver chip is also using that diode and capacitor to do this. That is my understanding. Yeah. Okay, now let's put some power into this board and see if it all burns down. We still have the overcurrent protection on my power supply, which means it acts as a smoke stopper. So if I get a current that's higher than 2 amps, that's me, I set it up to be 2 amps. If it goes over 2 amps, it's going to trip and stop. So that way, if I shorted something or messed it up, it will not burn the electronics. Okay, let's go to the screen share. And let's see if first thing is going to be, do all 4 motors come back to life? So are the red text going to go? Yeah, so I did manage to put the MCU back at least to some extent well, and now we spin. Okay, so I tripped my OCP, and I think one motor doesn't spin, the one I fixed. So I'm gonna try now, I put it back up, and I'm gonna try all motors beside this one, see if they work fine. Okay, this works fine. This works fine. This works fine. But the last one is probably gonna trip. No, it works fine. Interesting. So maybe I just tripped my OCP by running all 4 motors, which is very likely. So, so I'll probably just trip my OCP. I'll remove the OCP. I still have some.
Accelerate.
Yeah, I accelerated too fast. Let's go. And we still have a lower RPM. Okay. So what are the chances? What could it be? So that wasn't it. The mystery stands. So it means I either need to start swapping passives or swapping FETs.
FETs, no, the caps.
Yeah, the caps. Okay, we'll do the caps.
Those 3 ones next to the diodes.
Okay, I'll do those. So what makes you think that? Do they are capacitors, or I can see if one is shorted to start with, I guess, but it wouldn't work if it was shorted, right? It would just cause issues. But
Yeah,
I can swap
maybe it's just cracked or has a different capacitance.
Okay, I'll do that. Oh man, I was really hoping that diode was it, but the behavior being exactly the same makes me think I didn't break anything new, so good thing is I managed to put all the components back together well. I'm quite happy with that already. But yeah, as I said, today we're chasing an issue. Go ahead.
You mentioned earlier that the FETs are just a switch, so the FET basically cannot be it. So either the driver cannot give the right duty to the MOSFET, and that's why you have lower voltage and also lower RPM because of that. So something related to the driver is, and because that diode was mechanically broken, maybe the caps are affected as well.
Yeah, I see. That makes sense. That makes sense. So that's M1. That would be this guy. All right, back to the scope. Let's see what we can see. I mean, I'm gonna see if I can. I'm guessing it's gonna be relevant, but I want to see if I can measure capacitance on those FETs, if I get any meaningful reading. So I'm gonna go to capacitor mode and see if I can read. So that's the bad one. Let's see if I can read the good one. So I'm reading, wait for it, 5 microfarads. Let's see, it takes a while to read capacitance. Let's see, hopefully they're all the same. I should read all the same. Yeah, that's 5 microfarads. Not exactly the same, but I'm guessing close to be within tolerance. Waiting for the auto range to pick it up. 5 microfarads. Now the ones from the thing that's dead. So this one is the suspicious one. So let's do it last. I'm such a showman. So that's the top one.
Measuring the circuit, but it should
Yeah,
be
I know.
around 1 mic.
Yeah, I know measuring circuit isn't really super relevant, but you might see something obvious.
It should be around 1 microfarad usually.
Okay. Let's see if this one has. I mean, it reads lower. It reads so it reads about 1 microfarad lower. Maybe let's swap them and see what we get. So I'll get the board that had the same driver. I'll get the caps. Oh, they look awful though on this one. Yeah, they look kind of bad, like as if they were corroded away. So I'll see if I can find a better board with the Fortune drivers. Isn't. Oh, that other one. That doesn't have the same drivers, but the caps will be good enough, right? Should be similar. Let's see if we can measure a similar value. Maybe that will tell us that are similar enough, but they're probably fine. Come on. It just doesn't want to measure at all. I might have not scratched the surface. No. They just don't want to measure in circuit. But I'm gonna assume that they are similar enough and grab a few of them. I'm gonna start by only swapping the one that was next to the diode that was burnt. I've got a few of them on this board. That's practically a massive component compared to. It's not very big still, but it feels bigger than the diode we just did. Come on, leave my tweezers. Leave my tweezers. It's bound to be a good way to have your tweezers not stick. I'm guessing cleaning them is probably a good start. Okay, we have a few caps. Let me push that board out, put the old, and I'm gonna clean my tweezers so I hopefully can get the thing not to stick.
Did you lose the one you took
No.
out?
No, I'm good. I have all 3 in a box.
It would be cool to measure it out of the system and see.
Yes, I will try to do that on the. I can try to measure the ones. I'll do a round of measuring and try to measure the ones I just pulled out, and the one I'm going to remove now, and see if I can not lose them. But I'm not super hopeful. So let's see this guy. This guy. Come with me. You can see the diode has melted. Oh, I managed to move the diode. There we go, it's back. Okay, so I have that one. I'm gonna try to measure it. Let's see. I have I don't know how good they are, but I have ordered for a few euros a multimeter probe tip that is a tweezer to try to help measure those. There you go. Let's grab my multimeter, and the thing that sucks is I need to be able to hold it for a while close to it for it to measure. It measures 5 microfarad, or maybe I couldn't get a good measure of it. I don't think I'm making good contact, am I? It's measuring 0. Maybe it's shorted. Let me check. I don't think it was, but you can always check. It's not shorted. All right, I think I should probably switch all 3, just in case, so I don't have to pull thing on and off. I'll just switch all 3. It's going to be good training for me to switch them anyway. So let's do that. And tweezers. Where did I put my green tweezers? Here. Let's switch all 3. Okay, I only got 3 from the other board, so I better not mess this up. I can always go grab more, but let's try to do it correctly. Tacked. I'm gonna just tack them and then reflow, even though I think I'm probably already good. This one definitely not. Yep. Okay, it's too high on my. Let's see if I can place it. Oh, well, goodbye. Goodbye, Cap. Hardly knew you. I'm gonna have to get another one. Oh, the one on the top left the chat. Yeah, it's not as easy as they make it look on the let's see if I can grab it on the short. Oh shit. Oh, and that's gone. No, I found a bunch of ones, but they're probably the ones I removed. So let me reflow the one I managed to put on correctly before I kind of ping it out, and I'll grab a few more from the donor. Probably need to reduce my airflow a bit. Again, I'm still on 50%. I'll go to 30, try to lower the chances I keep messing it up. And let's reflow this guy. Hopefully it just flows into place on its own. Yeah, there we go. That's good. Yeah, let's quickly grab a few spare ones from the board. At least it's quick. It might take forever because I'm on 30% airflow, but there we go. Your friend and your friend. There we go. I think my other board is still hot because I was quick enough, so hopefully I can do it quickly. And same player plays again. So now it's going to be tacked. I'm going to reflow it now so I don't blow it away when I do the last one. There we go. Coming from above and wait for it to sit in place on its own, like a big boy cap. Come on. You can see the pad is unmelted, so it's not even close to melting yet because the pad is leaded. There we go. The pad is melting, so that shouldn't come too far, be too far away. There we go. Good enough. And let's do the third one. I still have 2 shots at this one because I pulled 2 caps. Okay, that cap is upside down. I'd rather have it the right side up so that the fresh solder is on the bottom. So let's see if I can do this without messing it up. There we go. There we go. Let me grab it again. Yay, it hasn't flown to Timbuktu yet. There we go. I managed to move the other one above. I'll reflow them both. There's definitely a skill to this. It's not something you can just hope to do well on the first go, I think. Because, yeah. Okay, that sounds good, looks good enough. And this looks good enough. Okay. That's... Okay, I'm not super happy about what this looks, so I might come with a soldering iron, a thin tip, and see if I can get some solder to flow a bit better here. I'm gonna do it the other way because, yeah, so I'm gonna put some flux, always flux, never enough flux. And I'll come and try to ensure it's all nice and melted with this iron tip. And it's probably a big pad, so it just doesn't want to melt. No, it does. It's nice and melted. That's good. Is it not doing it here? I'm going to use the more powerful iron with the smallest tip I have, which is this one. If I can get it to work. Sometimes it just doesn't want to start up. Oh, it does want to start up. Is it about to glow red on me again? Oh no, we're good. We're good. It's not going to have to glow red on me. And yeah, I'll commit with some hot air on with my right hand to kind of warm up the area, so I can get a nice. Yeah, I think we're probably good. I think we're probably good. Yeah, it's not the nicest looking thing, but it's on there. So good enough. Let's clean it up. Hey, shucks.
In the future, I would recommend just using the soldering iron for sticking new caps on there.
Okay, I might try that. I need some training. But yeah, I think I probably want to use the preheater if I'm doing that, because it looks like, which I did receive. I just haven't plugged it in yet, because the iron didn't seem to want to heat up those small things.
Well, at least on these bootstrap caps, you don't have ground on either side, so it's easy to heat up.
But one of them is the motor pad, which is, I'm not sure, maybe I wasn't having issues and I couldn't see, but it felt like it wasn't melting correctly. Well, so what are our chances now? I only soldered 2 motors because we don't need more than that. I'm blowing on the board once again to cool it off. I should probably make myself a small fan or something to cool the boards off faster. Oh, I found there's one of the caps that I blew away is here on the board. Oh, it goes to the bin. All right. I can hold it. It's cool enough. Let's see what goes. Do we still have the issue? I mean, after that, I don't know what it could be. If everything else is good, is there more passive that we could be? Or is it going to have to be the FETs in somehow? Some gate capacitance that's gone up for some reason. I don't know if that's... I'm guessing pretty much all failure types are possible with electronics. Always can surprise you, I guess. But let's hope this fixes it. That'd be an interesting fix to those issues if it's mostly the caps that need changing. That'd be interesting. Because that's not an easy, a hard fix. It's a bit of a tedious one, but yeah, there we go. Let's try this again for the 20 millionth time. It's actually only the 3rd or 4th time, but you know, you see what I mean. There we go. There we go. USB. So once again, we're looking for only motor 1 and 2 spinning because I didn't wire the other ones. And we're looking for a similar RPM on both. And turn it on. Let's try ramping it up slowly so I don't trigger my PSU. Nope, still the same. Well, I'm out of ideas, so I'm going to start swapping FETs, I guess, because I don't see how it can be anything else. We've swapped pretty much everything or checked everything. Could be some more passives we haven't checked. But yeah, it's going to have to be the FETs that we do next.
That would be a first.
Yeah, there's a first everywhere. But if I swap the FETs and it doesn't change, at least I know it's not the FETs. And I have one more confirmations that it can't be the FETs. I don't really have any better idea, so yeah, gonna have to be that. Let's see if I can swap all the FETs without making too many mistakes in swapping the FETs. I'll try to do them without having to keeping the original solder and everything, so I do it quicker. Don't want to spend all day swapping FETs. Let's try also not to do it on the wrong motor. So I'm guessing the last FET is on the back. Yeah, it is. So let's start with that one, I guess. Let's go back to microscope view. So let's remove this guy.
You could also have some resistors that are not quite right on the
is it
sensing. I don't know.
Is it worth testing them in circuit? I can do a tour. I mean,
a comparison maybe.
Yeah, that's the nice thing about
but the resistors close to the MCU.
Yeah, I'll compare all the resistors that exist. I have an easy A/B test.
You see those 6 ones.
Oh, I tested those ones. That's the driver. So you're talking about those 6 ones here?
Yep.
I'll test everything. I'll start with that. And 10K. I mean, I'm guessing that's just a test point resistor anyway. 10K. This one. 1K. 1K. Yep. Let's try those. 10K. I'm guessing they're all going to be the same 10K. Huh. 4K. And 1K. So 10K, 4K, 1K. Let's see on the good one.
Actually, I think they are 10K, 10K, and 1K.
Let's see. This one. No, they're 10K, 4K, 1K. In this case.
Yeah, but they are in the circuit.
Oh, yeah. Yeah. I see what you mean. Yeah, in circuit, at least they're measuring the same on both. Yeah, obviously. So that's 4K, 10K, and 1K. Yeah. So 4K, 10K, 1K. Yep. What about this one's 1K? Oh, 4K. 10K. 1K, I'm guessing. Yep. I mean, that's reading. Yes, that's reading a bit lower. 93, 9.3, and this one is gonna does it read lower as well? Yeah, there is this. Oh no, that's 10 on the dot. Wait, that's 10, and that's supposed to be 10. And it's only 1, so they're not in the same order on this one, I'm guessing. Oh, let's see. Let's see what I get here. 4K. 1K. 10K. And that's 4K. 10K. And 1K. They're flipped. Yeah, because they're traced to the FET isn't the same. But the 1K is in both cases 93. So we are the same everywhere. Those I haven't tested. Those are the 10 ohm resistors to the gate driver. Well, no, wait. That's a 10 ohm, then 1K, 10K, 10K, and 10 ohm. 10K, 10 ohm. And this is 10K, and 10 ohm. Yep. Yeah, they all test the same. Tested every single one of them. So, I mean, this capacitor, maybe, can I measure it to see if it gives me a reading? I didn't test this one.
That small capacitor on the driver could be also the problem.
Let's see what we read here. Do we even read something? It's possible that we can't read it in circuit. Yeah, I'm not getting anything. Oh, 40 microfarad after 10 minutes. And let's see if we get something similar here. After 20 minutes again. Yep, same thing. Okay, well, I think I'm swapping FETs. Do we have a... Yeah, I mean, I want to get down to... I want to find the issue, so I'm committed to swapping FETs and see what happens. Let's remove them. Let's take them from the donor first. So this donor uses the same FETs. Which are, I learned, alpha and omega FETs. And let's go full blast and remove a bunch of FETs. I'm gonna need 6. Do I need bigger tweezers? Yes, I need bigger tweezers. So yeah, that's an interesting investigation, but at the moment we're still no closer to, well, we are closer, but we still don't have no idea what exactly the issue is. That's fun. Once it's hot, it's very easy to remove them. Let's do a few more for good measure. So if I need them, I can put them in a box and I don't have to remove them from a donor. This one's tied to his friend. There we go, we have a bunch. And now we'll take our FETs, put them into a FET board. Now we're going to remove probably perfectly good FETs from the other boards, but you know, you got to do what you got to do. So we have 5 on this side and 1 on the other side. So let's go. Since I don't know which one it could be, I might have been able to tell with an oscilloscope, but I don't have an oscilloscope, so I won't be able to tell. Just double checking that I am indeed on motor 1. We don't want to start remove motor fetch from a motor that's working well. Let me position myself to a better position. I'm burning my hand here because of the hot air. Oh shit, I'm burning my hand. It's not enjoyable. That is not, I'm burning my hand. Just the airflow is getting redirected to my left hand, and it's it's awful. Let's see if I can find a way to make the air go elsewhere. Nope. Come on, boy. This one doesn't want to come off. Why don't you want to come off? There we go. Yep. I'm not enjoying this. I'm burning my hand again. This is not enjoyable. I might need to invest in some gloves. There we go. Now we need to do that on the other side, but you can put some new FETs on now while it's nice and hot. Try to... Where's my FET box of FETs? I put some flux on, and I'll see if I can get away with just putting them back on like this with no extra solder. So I need to put them in the right way around. So there's a shiny thing under them that tells me which way is good and which way. I'm going to try to reflow them all at the same time, try to kind of speed this up. Hopefully it works. We'll see. It should be obvious that they are the same directions at their friends, same orientation at their friends. We'll line them up better just in a second. Yep. There we go. Let's line them up. And then I'll come with some moderate heat and try to reflow them all, flow them all into place. It's not a reflow because they're not yet installed. I'll come with like 40% airflow. Try to not blow them off. That might take a while, but hopefully it does the job. Here we go. I'll start with the middle ones so that they're probably the ones that are going to need the most heat. So once they're done, I might need some more flux in here. Let me drop a bunch of flux up and put them back on. Come on, flux. Oh, I'm pressing on my flux and it's blocked. Take a second to fix that. Come on. Oh, I hate my flux is blocked. There we go. I think it's unblocked. I'm going to put a bunch more flux in all over. Never too much flux. And line them back up. And come back with the hot air. I can probably start heating it up while I line them actually. I want to float. Or is that a bad idea? Probably a bad idea. Yeah, good enough. I'll sit them right in when it melts. It's gonna take a while. You should see the pides become shiny around when it's hot enough, so it's gonna take a while. There's a ton of heat in sport. There's a ton of thermal mass in it, so it takes a while to heat up. Especially. It's nowhere near melted yet. Oh, come back. Come back. Well, I can keep heating at least. Well, and grab it. It's probably not a good method trying to put them all at the same time, is it? I probably should have gone full blast while holding the chip, tacked it, and then reflowed. But leave them down. Also, I probably use my preheater, but I'm trying to rush this before the end of the stream. And yeah. Oh, there we go. Now it's melting. Is it melted? It's melted on the back, so it's probably melted on the front as well. The front is the business end where there's the gate. Or is it? Oh, it's not. Okay, it's just. It's only melted once on one end, on the end that has the easy pad to melt. Yeah, this hasn't melted yet. I want this to melt. Yeah, preheater next time. I'm not even sure it's melted yet. No, it's not. Just doesn't want to melt. Okay, I'll probably do it another way. I'll remove them. And oh, maybe I do it that way. Drop it after it's melted. And now it's good. Maybe it has melted. Oh, it's hard to say. Yeah, I think it's I think it's good. There we go.
I came late to the party. What kind of ESC is this?
This is a cheaper one, but I'm trying to figure out. Hopefully I didn't hit them too much and they're dead now, but we'll see. It's an ESC that has a channel that spins slowly, and we're trying to figure out why, and we pretty much swapped all the parts possible, and it's still slow, so I'm doing the last part I can think of, which is the FETs. So we swap the drivers, we swap the MCU, which I managed to do without breaking the board, I must add, which is quite satisfying. But yeah, I just have one MOSFET to remove still and swap out. I'd be surprised if the thing still spins, given how much heat I put in the board. I wouldn't be surprised if I basically destroyed it now, but we'll see. We'll see. Come on, it's hot. Getting burnt. Okay, let's grab the FET in the box of FETs. That's going to be this way. Add some flux. If my flux wants to function. I'm pressing my flux as hard. Shit, stupid flux. Stupid flux. It's not time to stop working. Oh, that was my fault. Okay, that was all my fault. I had my flux press thingy bottomed out. Okay, let's see if I can. Oops. Come on back. Come on. I'll reflow it. I'll reflow it. Probably should reflow the other ones as well on more airflow. 70%. Yeah, I think we're good. All right. Let's see. Let's see. Let's see if I killed it. Hey, the Dronista. Welcome to the stream. You're really catching the tail end of the stream, but I can give you a quick rundown of what we did because it's interesting. So I have this ESC here that has a motor that's been slower than the others. So first, I thought, yeah, it must be the MCU. So we swapped the MCU between two of them and didn't change the issue, so I put them back. Then we thought, oh yeah, so it must be the drivers. So we swapped the drivers for non-good ones, and it wasn't it. So it must be the passives, right? And I noticed there was a broken diode here. So I swapped the diode and didn't fix it. Swapped the capacitors, didn't fix it. So having no other real good idea of what could be, I swapped all the 6 MOSFETs. And I might or might not have put them back the right way. I might not have heated the board way too much. So it might not even work at all now. But at least if it doesn't work, well, I guess I know not to stay on the heat too much or use my preheater maybe. I didn't melt the plug too much, so that's good. I am now blowing on the board to cool it off because it's very, very hot. if here it works and the motor is still slower, I mean, could be the motor, but it would have developed this problem very recently because it didn't do it on all the other tests on the bench. But I will swap two motors. It would be funny if the ESC was fine from the start and I have now bricked it. But it will have been a very interesting learning experience swapping all those things and swapping it mostly successfully, so that would be good. All right, let's put it back. Oh, it's all sticky.
Time for me to go to bed. See you, Uncle.
See ya. Have a good one. So we'll only do two motors as we did before. And first I'm gonna see if it even spins, because, you know, my work is not really, I'm not super confident in my work. He's resoldering all the FETs in one go. Like that wasn't the greatest of ideas, so I'll be happy if it spins. And we'll take it from there. Right. Let's give it some juice. I will manage to plug this at some point. There we go. Okay, let's see if we get, I'm gonna put OCP, overcurrent protection, to. There is some amount of light, but not many lights from this guy. I think I might have balked it. They will need a reflow. And it's not dead, it just means I need to reflow my things, but we'll see if I can get motor 1 to spin. I'm guessing it's gonna stutter like crazy. Yeah, yeah, I messed it up. That's fine, I just need to reflow the things. Yeah, thank you, Dronista. It's getting better every time. It's getting better and better. But yeah, I think I just need to reflow all my FETs on the top. Yeah, that's probably it. So I'm gonna give them a quick go. And if they don't work, then I'll probably have to spend some time off stream trying to see if I can fix them. That, I know it's a bit anticlimactic for the end of the stream, but I do really want to know if FETs can cause this issue, which supposedly they can't, and I kind of understand why they couldn't. But you know, when you're out of options, you kind of have to look at the, what's the expression? When you tried everything, whatever is left, however improbable, must be the answer. Something like that. So let's go full blast, or almost full blast, 80%. Let's go max heat. Put some flux.
It could just be the PCB.
It could just be the PCB, yeah. That is true, yeah. Those are definitely cheapo PCB. They're definitely built down to a cost. So I think that could very well be the case here. I think this one is probably fine. I feel like this one is probably fine, but I could check continuity as well. If this doesn't solve it, I can check continuity. But I could also like go back, put some leaded, do it like the right way. It's probably the way I should have done it, but I wanted to try to fix it before the end of the stream. Yeah, I think that at least one of this was the first one wasn't seated right. I think this one neither. Oh, what's this between them? Oh, that's not between them. Okay. Okay. I think that's as good as I can get it without redoing it properly. So let's see if at least we spin. And it feels like this guy isn't soldered correctly, and that's probably the bit. I can try retouching it with the iron. Let's do that quickly while it's hot, and put some flux on. Some solder. Oh, yeah, it is hot. I don't know which one is the gate, but the other one looks quite good. So, yeah, let's assume it's decent. Let's assume the rest is good. Let's see if it spins, and then we'll end the stream there, regardless of whether it spins or not. But did I? No, I think the other side one is quite. I was quite happy with. So let's blow on it, put it back on, and see if we at least get the motor to spin again. Jonista asks how much I charge to repair. So basically, first of all, I'm still learning, and I definitely wouldn't have the confidence to charge for repairs. Secondly, I just don't have time, so I don't do repairs for people. The way it works in my group is people give me stuff that they are going to throw away and that they wouldn't be able to do anything because they can't really send it for repairs. There's not many services for repairs. They just give me the things, and I have big boxes of dead stuff. And then on stream or off stream or whenever I feel like it, I fix them or I don't. There's no real tracking of who gave what or whatever. And then I put everything in a box, and the friends who need the electronics for a new build because they burned something or anything, they get to pick in the box for €5 each, just to pay the spares, basically, pay for the spares, because I do have to buy MCUs and stuff like that. And I don't think I would ever be in a position where I have enough time that I would want to spend that doing repairs for others, unfortunately. So it's basically a give me your stuff if you feel like you're not going to use it, and maybe you'll be able to buy a very cheap board, repaired board. And a bunch of friends now are all are flying on repaired boards. For me, it's a way to just stop electronics from going to the bin. I get a lot of satisfaction out of repairing stuff, and it doesn't really go beyond that. It's not, I don't really do it, I wouldn't do it for the money. Ducky Productions, don't worry, there will, you've missed the stream, but there will be on-demand. You can always watch it later. I know it's not the same, but if you want to see me change pretty much all possible components on an ESC, that being MCU, driver, FETs, and stuff like that, well, that's the stream for you, because we're trying to diagnose a board that has a motor that's been slower than the other ones. And now we are at the point where I swapped all 6 FETs. I did it too fast to try to get it into the time for the stream, and then I didn't do it well. I didn't spin. I tried to fix it right now, and we are hoping the motor will at least spin now. But I might have broken everything, overheated everything. I might have messed it up, basically. So we don't know, but we're gonna know right now if I manage to get it at least spinning again. Because that's a very common issue we run into where, oh, what's happening? Oh, my power supply is still on. So I had sparks trying to plug this, and because it's charging the capacitors. All good, that's on. Let's see if this lights up at least a bit. Oh, that lights up better. Okay, we might have a spinning motor again. Let's have a look. Yeah, the Dronista, I hear you. You have a lot of dead things. If you can find someone willing to repair them, that would be awesome for you. If you ever feel like then you're never gonna do something with them, you can donate them to the stream. Though I still have a very, very huge backlog of things to go through. But then if you see me in real life, you can have your pick in the box. Oh, it's spinning again. We fixed it. Now, is it spinning at the same speed as the other one? It is not. So it wasn't the FETs. So we still haven't fixed it. So it's probably the board then. Has to be the board. I think it has to be the board. So it has to be completely dead. We swapped everything, every single component, besides the ones we could measure as being good. There's nothing we haven't swapped. So I guess that's the lesson for today. There are cases, not all of them maybe, where if you get a motor that's been slower, you're probably SOL. I'm super happy we got to reflow and fix the FETs so that it actually spins. That's really nice. But yeah, can't think of anything that it could be. So yeah, maybe it's this cap. Maybe, I mean, I'm gonna do one last thing before we disconnect. I'm gonna measure this cap, and maybe it's gonna be the one thing I haven't swapped. And maybe that's gonna be it. I'm not very hopeful though. I am going to measure this cap here, which is a known good channel. You can see the values display on your screen. It's going to display at some point. It takes forever to measure. Or maybe it won't measure in circuit. It's possible it just won't measure in circuit. Yeah, it doesn't seem like it will. Doesn't look like it will. Oh well. I mean, I can test if it's shorted. That's the beep mode. And I'm guessing it's not shorted. It's just reading, so it's reading some ohms. And it's reading the same, I think, here. Let me try to get my probes on it. I hate it when I don't solve the mystery. Okay, so it's just not conducting at all. And here, does it stop conducting at some point? Huh, interesting. This doesn't stop conducting. There is some ohms difference. Well, this, the good one, and I'll test another one, they kind of conduct at the start while I charge them. Okay, so same thing is happening. Okay, I was hopeful, but it doesn't. And this one's on the left. Okay, they're probably not set up the same way, but the one on motor 2 is doing the 775. Okay, so probably not it. No, it's not. It's not it. That's not it. Well, thank you everyone for coming to the stream. I'm sorry we didn't get to the bottom of this mystery. I mean, I guess the next thing to do is to find one that works, one of those ESC that works, and then swap all the components to the other board to rule out the board. And that's not something I'm ever going to do because there's way too many components on the other side. And this is, I remind you, probably a 25 to 30 euro ESC, so it's not worth the time. But I was really hoping we would get to the bottom of it by swapping one of the main components, but we didn't. So yeah, that's the stream. Probably back to doing some more actual fixing of stuff next week. But I will always try to bring interesting new things when I get them. Like we did the camera pad repairs on Thursday. It's in French, but it was very interesting. We had tiny pads on the ripped out component on an analog camera, and we managed to fix that. That was super satisfying, even though it wasn't super pretty. But yeah, for all of you who want to come to the French stream, you're welcome to come. I welcome you in 2 days on Thursday. Otherwise, I will see you all next week on the English stream on Tuesdays. While I have your last minutes of attention, it would be super nice if you wouldn't mind clicking the like button on the stream. Possibly leaving a comment would be good. Just say what you liked, what you learned. If you hated it, if you hate me, if you hate my face and you stayed for 2 hours, hating my face all the time, it's really good for the engagement, for the app and the algorithm and everything. So I would be super grateful if you could spare the second. All right. I will see you next week or on Thursday. Have a good one. Bye.